Welcome friends. Today we are going to start chapter number 2 of class 10, which is acid, bases and salts. In acid, bases and salts, first we have to know about acid. Now what is acid? How can we describe acid? Acid can be described in some criteria like they will be sour in taste, then they will turn blue litmus red, then they will have hydrogen positive ions in aqueous solution, then they will corrode metals. Now if we see some examples of acids, in strong acid we can see that there will be many acids. I will be giving you some examples like in strong acids hydrochloric acid, then there can be sulfuric acid and etc. In weak acid, if we look at the weak acid, there can be acetic acid, then there can be oxalic acid, then there can be citric acid and many more. Now what is concentrated acid? Now if we look at concentrated acid, then when concentrated acid means in which the percentage of acid will be high and the percentage of water will be low. Now what is dilute acid? In dilute acid we will see the percentage of acid will be low and the percentage of water will be high. Then if we are given a concentrated acid, how can we will make dilute acid? If we add some water in it, in the solution becomes dilute acid. So these are some concepts you should know, so that's why I provided this. Now if we look at the base, now what is base? How can we say that the substance we have given is a base? So there are also criteria to know that they will be bitter in taste, then they will turn red litmus blue, then they will give hydrogen negative ions in aqueous solution, then they will be soapy in touch. Soapy means like foam, we can say it will be foam like substance which you can see in many detergents and soap etc. you use at home. Now for example of base, if you look at the example of base, there are strong base and weak base. So if we look at the first strong base, we have sodium hydroxide, then we have potassium hydroxide, then we have calcium hydroxide. Now in weak base, now in the example of weak base we have ammonium hydroxide and etc. If we look at now a question comes is alkali. What is alkali? If you look at what is alkali, these are nothing but these are also bases which are soluble in water like NaOH, sodium hydroxide. Next comes is indicators. Now what are indicators? Like first of all a question comes Imagine I have given you a substance called X. Now tell me, what is this? Is it acid or is it base? So how can you tell that is this acid or base? Some of you may be thinking about tasting it, that if we taste the acid, if we get the taste as sour, it will be acid. If we taste it and get the taste bitter, then it is base. But in chemistry, we people are not allowed to taste substances because these are highly dangerous and cause many severe problems. So then comes the work of indicators. These are the substances. These are the substances which changes their color, and smell in different types of substances. There are types of indicators. And there are 3 types. The first is natural indicators. If we look at the natural indicators, these are those indicators found in nature, we can say in plants, called natural indicators. For example, let us take litmus and turmeric. In Hindi, turmeric means haldi. Now, how can we say that is this acid or base? If we give the substance and the litmus turns red, then this is acid. And we drop the substance in litmus paper, if it turns blue, then it is base. Now in turmeric, it is already yellow. So if we give the droplet in turmeric, we get yellow, then it is acid. And if it turns to red, then it is base. Now the second indicator is synthetic indicator. Now what are synthetic indicators? These are chemical substances which are prepared in laboratories. Okay, now for example, if we take methyl orange and phenolphthalein, now how can we say that the substance is acid or base? If we put the substance with methyl orange and if it turns to red, then it is acid, and if it turns to yellow, then it is base. And in phenolphthalein, if the substance turns colorless, like the color of water, then it is acid. And if it turns violet or dark pink, then the substance is base. Now comes the third indicator, and the third indicator is olfactory indicators. Now what is olfactory indicators? These are the substances which have different odor. Odor means smell in acids and bases. Now, for example, if we take vanilla essence and clove oil. If we take vanilla essence and clove oil, now let us test that the substance is acid or base. How will be the odor of these substances? If we keep the substance with vanilla essence, and if the smell of if the odor of the substance gets higher in percentage, then it is acid. And if we put the vanilla essence with the substances and the smell gets disappeared, then it is base. In clove oil also the smell gets higher, and which is known as acid. And and when we put the substance with clove oil, and if it is base, then the smell will go downwards. So these were the three types of synthetic indicators we have to know. Now let's come to chemical properties. Chemical properties of acid and bases. Now if we go to chemical properties of acids and bases, there can be, first we can learn about the reaction of metals with acid and base. Now if we look at the reaction of acid and base, now let's see the reaction of acids and bases with metals. So first of all we check for acid, which is acid plus metal reacts is salt plus hydrogen. How can we check? Let us take acid as hydrogen chloride, then the metal as zinc, Zn. So we get the product as ZnCl2 plus hydrogen, which means the ZnCl is salt and the hydrogen releases from the reaction. So this can also be known as displacement reaction. And next, let us react with base. When we take base plus metal, then we get the reaction is salt and again salt plus hydrogen. Now let us check how. If we take sodium hydroxide plus Zn as metal, then we get Na2ZnO2 plus hydrogen releasing. Now here this is also a salt, which is known as sodium zincate. So in both the reaction we can see that when we react acid and metal or base and metal, we get the product as salt and hydrogen. So how to check that we are getting hydrogen gas? Now open your textbook and see the figure 2.1. Here you can see that it is activity on testing of hydrogen gas. Now we come to testing of hydrogen gas. Now if we look at the activity, there is a figure which is allotted and I am unable to draw here. So I'll be drawing a simple diagram which I think you can understood. This is a test tube in which here are some zinc granules. Then there is a liquid form which is dilute sulfuric acid. Then here some oxygen also present here, which is hydrogen gas bubbles coming out of the zinc granule. Then there is a cork fitted here and one delivery tube is adjusted inside it between the cork, and here is a bucket of soap solution. And the delivery tube is entered inside it. So the gas, hydrogen gas bubbles coming out of this beaker goes to the soapy solution, that is soap solution. Now when the gas bubbles are coming out of this beaker and going to this soapy solution, then these hydrogen gas bubbles turns into bubbles and comes out of this soapy solution. So if we put a candle here and light the candle, when these bubbles will come in contact with fire, then we will hear a pop sound. And here we come to a solution is that hydrogen gas released can be tested by bringing candles near gas bubbles. It bursts with pop sound. Now we can say that in this complete reaction there was hydrogen present in it. Now the next topic is reaction of metal carbonates and metal hydrogen carbonates with acid and bases. First of all we will see with acid. Now let us take acid plus metal carbonates and metal hydrogen carbonates, then it will give us product as salt CO2 gas plus H2O, which is water. Now we have to check our answer. Is this possible? Like example, if we take example of acid, which is HCl, plus if we take hydrogen chloride plus sodium carbonate as metal carbonate, if we take HCl as acid and sodium as metal carbonates, then we get the solution as 2NaCl, which is nothing but salt plus carbon dioxide as gas plus H2O water. Now next is, if we take acid plus metal hydrogen carbonates. Now what is metal hydrogen carbonates? Sodium plus hydrogen carbonates. Then we get a product is NaCl, which is sodium chloride, which is also a salt. We get plus CO2 plus H2O. Now in bases do not react with metal carbonates and metal hydrogen carbonates. Now in the reactions earlier, we have seen that there is a common substance present, which is CO2. Now we have to check whether CO2 is present or not. So how to check CO2? So now testing of CO2, that is carbon dioxide. CO2 can be tested by passing it through lime water. So what is lime water? CaOH2, which is lime water plus this CO2, which gives us a product which is CaCO3 plus H2O. Now while we have done this reaction, we have got the product CaCO3 plus H2O. Now during this reaction, there is also CO2 passing through it, which is continuously passing through this reaction, which is when excess CO2 is passed. When excess CO2 is passed, we take this solution CaCO3 plus CO2 plus H2O. That means CaCO3, H2O and the excess CO2. Now we get the product is CaHCO3, which is colorless, and this is milky white. So now we come to a conclusion that when we pass CaOH2, when we pass CO2 through this lime water, we get a solution CaCO3 plus H2O. If the CaCO3 is milky white, then we take the excess CO2 and take this reaction. If we get the product as colorless, then we can say that this in the above solutions or the above reactions, CO2 is present. Now the next property is reaction of acid and bases with each other. Now what is the reaction of acid and bases with each other? We look at like this. When acid and base reacts, we get product as salt plus H2O, which is water. For example, if we take acid as hydrogen chloride plus base as sodium hydroxide, then we get salt as sodium chloride plus H2O. This is called the reaction of acid and base. Whenever we will react acid plus base, then we will get the solution which is salt plus H2O, which is water. Now what is neutralized? What is neutralized reaction? In neutralized reaction, when an acid and base react to form water and salt, it is called neutralized solution or reaction. Now in acid we get hydrogen positive ion, and in base we get hydroxide negative ions, and these two gets the formation of H2O. It involves H plus ion plus hydroxide hydrogen plus ion plus hydroxide ions reacts to form water. Now the next topic is reaction of metallic oxides with acids. Now how can we check that the reaction of metallic oxide with acid? Now first of all we have to know what is metallic oxide. Metallic oxides are always basic in nature. These are anything like any metal like Ca, which have oxides, that means CaO, and like magnesium, Mg, then we add oxide to it, which is MgO. Now the reaction: acid plus metallic oxide reacts salt plus H2O. How? We take acid as HCl plus metallic oxide as CaO, then we get the reaction as CaCl2 plus H2O. Now let's balance the equation. We check calcium is 1 1, chloride here is 2 and here is 1, and here oxygen is 1 1, then again hydrogen 2 and here is hydrogen 1. So this gets balanced. Now if we look at the solution, this is a salt, this is a metallic oxide, this is acid, and this is H2O. Now next is reaction of non-metallic oxides with bases. Now what is non-metallic oxide? Always remember, non-metallic oxides are acidic in nature. Now let's take a base, then react with non-metallic oxide, then also we will get what? Salt plus H2O. Now what is base? Let's take base as CaOH2 plus non-metallic oxide. See, carbon is a non-metal, and let's add oxide to it, which is CO2. Now we will get a solution which is CaCO3 plus H2O, and here CaCO3 is again salt. The next point is, what do all acids and bases have in common? Now let us check what these acid and bases have in common. Now in all acids, the common thing is, number one, all acids have hydrogen positive ions, and the next one is, these hydrogen positive ions are responsible for their acidic properties. So here we come to know that all the acids have hydrogen positive ions, and these hydrogen positive ions are responsible for all the acidic properties that the acid produces. Now next, for all bases. For all bases have hydrogen oxide negative ions, and these hydrogen oxide negative ions are responsible for their basic behavior. So we come here that all the bases have hydrogen oxide negative ions, and these hydrogen oxide negative ions are responsible for all the basic nature of the bases. Now the next topic is, what happens when to an acid or a base when put in a water solution. So acid and bases in water solution. Now let us take acid. Here H positive ion plus H2O water, we get H3O positive. Now this is called hydronium ions. So if we take H positive ion as HCl, when we react with H2O, we get H3O positive plus chlorine negative. So we can take out a point here that H positive ion, that is this ion, cannot exist alone. So H positive ion cannot exist alone. They exist as H3 positive, like this, or So now the next topic is acid and bases in water solution. Now if we first take acid, we take H positive ion plus H2O, which reacts, and we get H3O positive, which is hydronium ions. In H positive, we take HCl, then H2O, then we get H3O positive plus chlorine negative. We get a note here that H positive ion cannot exist alone, so they exist as H3O positive, which is hydronium ion. Now in bases when dissolved in water gives hydroxide negative ions, which is NaOH, when reacts through water gets divided, which is sodium positive ion plus hydroxide negative ion. So we come up here with the solution of water with acid and bases. Now, the universal indicator. It is a mixture of several indicators. It is a mixture of several indicators, which means that the litmus, the turmeric, the phenolphthalein, methyl orange we studied earlier, it is a mixture of all the indicators. It shows different color at different concentration of hydropositive ion, which means whenever a solution is given, we have to check the concentration of hydropositive ion present in it, and according to it the pH shows the color present in it. Now this is a pH table in which we can see here are numbers given from 0 to 14, in which 7 is the neutral one, and going this side from 7 shows us the acidic nature increasing, means at this point in the table the acidic nature is much more higher than the number 6, and going this way from 7 shows us the basic nature of the solution and increasing by going number to the second number. Now you can ask me that how bases shows hydropositive ion, because bases doesn't show any hydrogen positive ion, it always shows hydrogen oxide negative ions. But going to the figure in the textbook 2.6 shows us the main reason of why this pH table is involved in acid and bases both. So in the textbook we can see that here are given the hydrogen oxide negative ion and these are the hydrogen positive ion. So now it is clear that both hydrogen positive and hydroxide negative ions are present in both acid and bases, but the concentration levels are different. That's why we can see a higher level of hydrogen positive ion in this side, in which acidic nature is increasing, and we can see that hydrogen oxide negative ions are increasing on the bases side of the table. That is why we can see that from 7 going to this side the basic nature increases. That's why the bases are going strong, and going this side we can see that the increasing of hydrogen positive ion, that is why it is showing us the acidic nature increasing. Now the next point is uses or importance of pH in everyday life. So first point is our body works between pH 7 to 7.8, which means if our pH gets increased by 7.8 or gets decreased by 7, it will create uneasiness to your body and which will be not good for your health. Now the next point is pH of rain less than 5.6 is called acid rain. When we measure the pH of the rain and we get the number as below 5.6 is called acid rain, which is not good for our health. Next point, our stomach produces hydrochloric acid. Whenever we take food, our stomach produces hydrochloric acid every time, and it's also needed to check because the increasing of HCl, the pH level of HCl increasing is not good for your health. Next, tooth decay starts when pH of mouth is less than 5.5, which means the tooth decay starts when pH of the mouth is less than 5.5. So to not get less than 5.5, we need to brush twice a day, that which will keep our teeth healthy every day. Now the next point is self defense by animals. When if you get bitten by a honeybee, the sting of the honeybee remains in your body, which creates severe pain. Someone can get fever and etc., which means the sting in your body is left, reacts with our body organs and releases methanoic acid, which creates problem to your blood cells and causes problem to your body. Now we have completed our knowledge about acid and bases. Now we come to salts. What are salts? Salt is an ionic compound formed by neutralization reaction. Now what is neutralization reaction? Which we have studied earlier, that the reaction of acid plus base gives us salt plus H2O, which is neutralization reaction. For example of salt, which is NaCl, which we use in kitchen, and CaCl, etc. Now chemicals formed by salt: sodium hydroxide, which is NaOH, bleaching powder, which is CaOCl2, baking soda, which is NaHCO3, then washing soda, which is Na2CO3 into 10H2O. Now next is plaster of Paris, which is POP, whose composition is CaSO4 into 1.5 H2O. Now we'll study about these chemicals one by one. Now number one, sodium hydroxide, which is NaOH, which is also called as caustic soda, CaUSTIC, caustic soda. Now when electricity is passed through an aqueous solution of NaCl, it decomposes to form NaOH, which means when NaCl is reacted with water, we get NaOH plus chlorine plus hydrogen, which means we have two points, one is cathode and one is anode. In this reaction, this is anode and this is cathode. Now let us complete the reaction, which is 2 NaCl, 2 H2O, 2 NaOH, and we get the reaction like this. Now remember that when the hydrogen is released from the cathode point, we also get this NaOH solution from the cathode. So salt is observed from the point of cathode. Now uses of the sodium hydroxide. Number one, it is used to make soap and detergent. Number two, it is used in paper manufacturing. Number three, it is used in oil refining. Number four, it is used in PVC manufacturing. Number five, also used as pesticides. Then the next is number two, bleaching powder. which is CaOCl2. Now it is produced by the action of chlorine and chlorine on dry slaked lime. Now what is dry slaked lime? Dry slaked lime is CaOH2 plus chlorine, then we get CaOCl2 plus H2O. Now when the chlorine is reacted with dry slaked lime, we get the bleaching powder plus water. Now the uses of bleaching powder: number one, bleaching cotton and linen in industries. Now bleaching is used for cotton and linen in many industries for getting the cotton and linen perfect. Now bleaching is used in wood pulp, in paper factories. Now what does this mean? When the wood pulp is prepared for making paper, it is first bleached and make it clean for making paper. Number 3, used as oxidizing agent in chemical industries. In chemical industries, it is used as oxidizing agent. Then disinfecting drinking water, which is a common use of bleaching powder. Now the third is baking soda, which is NaHCO3. Now how we get baking soda? The formula is NaCl reacts with water, reacts with carbon dioxide, reacts with ammonia, gives us ammonium chloride plus baking soda. This is the formula of baking soda. Now by reacting now baking sodium chloride plus water plus carbon dioxide plus ammonia gives us ammonium chloride plus baking soda. Now these have some properties in it, which is number 1, it is mild, that means it is soft and non-corrosive base, which means it lasts long. The next is when it is heated during cooking, that means this is one of its use. It is used in cooking and gives us the formula 2NaHCO3 gives us sodium chloride, the sodium carbonate plus water plus carbon dioxide. Now the uses: number 1, an ingredient of antacid. What is antacid? When someone gets a problem of acidity, he takes antacid. Now the uses of it: number 1, an ingredient and as antacid. What is antacid? When someone gets the problem of acidity, he takes a pill or a medicine which is antacid, and baking soda is used as ingredient of antacid. Next is used in fire extinguisher. Why it is used in fire extinguisher? Because there is CO2 present in it, because CO2 is a good source to stop fire. Next, for making baking powder. How it is made? Baking powder is made by baking soda plus tartaric acid. Now, use of baking soda, you know that, used in breads and cakes to make it soft and spongy. Now, the fourth is washing soda, whose chemical formula is Na2CO3 10H2O. Now, what is 10H2O? 10H2O can also be called as decahydrate. 10 means deca. Now, what is washing soda? Recrystallization of sodium carbonate gives washing soda, and it is basic salt. It is basic in nature. Now, if we take Na2CO3 and add water in it, then we get Na2CO3 into 10H2O, which is also called as sodium carbonate decahydrate. Now let's check the uses. Number 1, in glass, soap and paper industry, which means in glass industry it is used for cleaning glasses, in soap factory it is used for making detergents, and in paper industry it is used to clean the paper. Now next is used as cleaning agent in houses. In houses there are many cleaning agents by which we can clean glass, dishes. It is used in the formation of those cleaning agents. Removing hardness of water. Some water have iron present in it, so when you wash the clothes with that water, it gets the color of iron. So before washing the clothes, the water is added with washing soda, then the water leaves its hardness and is easy to get clean the clothes. Now the fifth and the last one is plaster of Paris, which is also known as POP, whose formula is CaSO4 half H2O, which we can say that calcium sulfate hemihydrate. Half means hemi. Now when heating gypsum, what is gypsum? Gypsum is something like concrete or any hard type of material which is formed when CaSO4 and 2H2O is the formula. Now look at these two formula. Here is half and here is 2. This half makes it plaster of Paris and this 2 makes it gypsum, which means when heating gypsum, this is gypsum, when it's heated at 100 degrees Celsius or 373 Kelvin, it loses water molecules, which is it loses its moisture and becomes plaster of Paris. It is a white powder. On mixing with water, changes in gypsum. Now the formula of gypsum, let's take the formula of plaster of Paris and change it to gypsum. Now take the plaster of Paris formula, which is half H2O plus 1 and half H2O gives us the product of CaSO4 into 2H2O. Now its uses: doctors using to support fractured bones, for making toys, then for making surface smooth. Like in your house, the walls are making smooth before it gets colored. It is the use of gypsum or plaster of Paris to make it complete smooth. Now here I finished the chapter and hope you have understood all the concepts. If anyone has any doubt in the concept of any part of the full video, please comment on the comment section, and if you like the video, please put a like and do subscribe.